This training tutorial explains the usage and configuration of the left taken object feature. Effective and rapid detection of abandoned and removed objects are more important than ever before, not only to prevent attacks on landmarks, public transportation and critical assets, but also for ensuring health and safety in the workplace. Leaving a bag in the parking area or removing a bike from the bus stop are examples that the left taken object software can detect, as shown by these two examples. Please note, by default, it takes 60 seconds for the alarm to register after the object has been left or taken, but to save time, I have cut most of this waiting time out of the video. Configuring the left taken object feature for use couldn't be easier. You just click on the Enable Disable tab and select the left taken objects button like so, and hit Apply. Going back on the Zones and Rules page, you simply create a zone like so. And hit Apply. If an object is left on the floor, then after 60 seconds an alarm event is generated and a red bounding box is drawn around the object. One word of caution: note that in the Moving and Stationary Objects mode, all the rules are enabled in the Properties Inspector except for the left taken object rule, which is grayed out. In contrast, if the left taken objects mode is selected, then all the rules are grayed out except for the left taken object rule. It is a common mistake to forget which mode the system is in, and so if the rule that you want is grayed out, it probably means that the incorrect mode has been selected on the Enable Disable tab. This finishes the explanation of the basic left taken function. This next section of the video explains how the blob metadata can be used for troubleshooting, and I will use it now to explain the underlying operation of the left taken object function. I will demonstrate two situations in the office environment, one showing left object detection and the other showing taken object detection. In both examples I am using the 60-second default settings shown here in the Properties Inspector, but once again I have speeded up the action by editing the waiting time out of the video. To switch on the blob metadata diagnostics, click on the Advanced tab and select the blob option under the metadata format and hit Apply. Next, go back to the Zones and Rules page and turn on the blob metadata like so. In the first case, a roll of tape is placed on a shelf. And so after 60 seconds, a blob map builds up where the object was left, showing where the algorithm has detected a change in the long-term background scene. This generates an alarm event and a red bounding box around the object. In the second case, if I remove a box from the shelf like so, then after 60 seconds you will again notice a blob map build up where the object was removed. This in turn generates an alarm event and a red bounding box is drawn around the removed object. It may be found necessary to reduce the 60-second time threshold in order to speed up detection, or increase it above 60 seconds to avoid some false alarm situations. It can be changed by clicking on the plus sign under the left taken object rule and changing the value like so. If we continue to study this video, we will notice that after a further 60 seconds the pixel change is learned into the background by the algorithm, and so the red bounding box disappears and the event end time is inserted to complete the event message. Notice that this further 60 seconds represents the stationary object hold-off time, which can be found on the Advanced page. This is different from the time threshold set in the left taken rule, and it determines how long it takes for a pixel change to be permanently learnt into the background scene after an event has been generated. The user may want to increase or reduce this time in order to tune the algorithm performance. One final point of note is that there is no difference in the system's response to leaving an object or to taking it away. In both cases, a left taken object event is generated. This is because the algorithm is only concerned with long-term pixel changes and does not differentiate the underlying cause of the change.